Hellos, everyone. Let's keep riding our horse, okay? And right now we are about to do 6.2. Okay, write a program that computes the sum of the digits in an integer. Okay, use the following method header. Okay, given a number like that, okay, we compute the sum of the digits. Okay, it's pretty straightforward. I don't know. So basically they're giving us a hint, which I don't care much about because I know the algorithm. Use a loop to repeatedly extract and remove the digits until all the digits are extracted. Write a test program that prompts the user to enter an integer and displays the sum of all its digits. Okay. Did they mention a method? Okay, sum of digits. Let's start by writing that method. There are different approaches when it comes to programming. Sometimes people find it easier to start by implementing the bigger picture of the program, or rather application or project. By bigger picture, I mean you forgot about the building blocks of the methods themselves. You simply write them, leave them as skeletons, and then later on I come back to those skeletons and actually do the coding. Okay, implementation. Okay. I don't know which approach to take. Whether to start by writing the logic for this method here, or whether or maybe to start by invoking it and then bother ourselves later about the implementation. You know what, let's do that, the second approach, for the sake of taking care of compile errors. What we want to do is to return something here. It could be anything. Okay, so here's what I'll do. As always, here's what I will start by doing. You see, they were never specific in regards to whether or not to take care of negative numbers. They weren't specific. So what my program will do is it will simply take all numbers into consideration. Okay, so if we have a negative number, we'll make it positive. Okay, but we could simply forget about this and then treat negative numbers the same way we will treat positive numbers. The algorithm will be the same. Okay, again, we learn by mistake. That's the idea behind this channel. I want people to learn by mistake. By mistakes, okay. The sum of digits is, again, this time around I don't see the point of having a variable to hold the retained value from the sum of digits method, so that's why I'm only going to invoke the method without bothering myself. Sum of digits, or for some digits, is that the term they use there? Okay, it is. Now we're done with our main method. Let's get to the core of this exercise, which is this method here. This is the method where we and sum. In fact, let me use long. Sum will do it. In sum, I mean an integer will do it. In fact, even a short would do it. Short. Okay, sum of digits. I'll keep doing this while number is greater than 0. If this is the case, I'll say sum equals to, this is the algorithm they explained to us. I didn't bother myself though about it, because come on, I know how it works, so I bother. Okay, so basically the first line extracts the last digits on our number, the rightmost digits, and then the second line, what it does is it updates our number by getting rid of the extracted digits. Oops. And then finally we wanna let's make that an integer, but it will also work even if because it will also work even though this is a short right here and up there we have an int, but it wouldn't have worked if we had things the other way around, if we had an integer there and a short up there, because the compiler would think we might have an overflow, so it will complain. Anyways, let's continue by hitting the run button. Let's try 1 2 3 4 5. So the sum of digits, that was so dumb of me. You see what's happening here? Since I'm using 100, this line here will extract 5, so now our sum is 5. However, the second line will update this number from 1 2 3 up to 1 2 3 instead of 1 2 3 4. So that's why we have got to get rid of 1 0 here, and then now it will work. Boom. That was so stupid of me. 1 2 3 4 5. Now it's gonna be this is 10, folks. There's absolutely nothing to bother ourselves about. Okay, so it's 5 plus 4, 9 plus 3, 12 plus 2, 14 plus 1, 15. That should be pretty much it, folks. See you on the next solution. I'm gone.